Now come to discuss another useful and important design principle, interface segregation principle, or in short ISP. This principle states that clients should not be forced to depend upon the interfaces. Here clients mean the derived classes should not be forced to depend upon the interfaces that they don't use. This means the number of members in the interfaces that is visible to dependent class should be minimized. In the field of software engineering, the interface segregation principle ISP states that no code should be forced to depend on the method that it does not use. ISP splits interfaces that are very large into smaller and more specific ones so that clients only have to know about the method that are of interest to them. This means clients will have access only to those methods where clients have a concern with those classes, with those methods. So if we have a big interface abstract class which have too many defined methods and clients which are inherited, the derived classes which are inherited from these abstract classes, does not mean that all the derived classes must use those methods. So this means we must have to, according to this principle, we must have to split, we must have to decompose that larger interface and abstract class into smaller favor number of abstract classes. So example, the service interface that is exposed to the client should contains only client related methods, not all. Now discuss the key components of interface segregation principle. So we have these few key concepts. First is granularity of interfaces. Instead of having a single large interface that include many methods, ISP advocates for creating smaller, more focused interfaces. This way clients only implement the methods that are relevant to them. So this means ISP assure the granularity of interface. This means the large interface will be decomposed into many interfaces, and this way of decomposition reduce the dependencies. So reduce dependency is another concept. By segregating interfaces, you minimize the dependency of clients on methods that do not need, leading to a more modular and maintainable code base. If an interface is too large, changes to one part of interface can affect all implemented classes. So this means if we have a large interface where too many defined functions exist and we are bringing some changes, so the derived classes can be affected, which can reduce bugs and complicate maintenance process. Improved flexibility. Smaller interface can evolve independently, allowing different clients to adapt to specific changes, or we can say when we bring changes in one interface will not affect another interface, or not only it will impact another interfaces, but also it will not have any impact, negative impact on the clients which do not have any access to this particular interface in which changes are brought. So small interface can evolve independently, allowing different clients to adopt to specific changes. This flexibility supports easier updates and swapping of implementations without impacting unrelated parts of the system. It also encouraging composition. ISP encourages the use of composition over inheritance, promoting designs in which class implement multiple specific interfaces rather than inherit from one large base class. Now come to discuss first, before coming to discuss programming examples which are implemented with ISP and without ISP. First discuss what is an interface. An interface is a set of abstraction that an implemented class must follow. We define the behavior but not implement. So this means using interface we define the behavior but not the concrete implementation. So this means we must have to derive the classes using inheritance. So inheritance is the property which must be used here. So the concrete implementation is the responsibility. The concrete implementation of this interface is the responsibility of the clients or derived classes. Here you can see we have defined the interface with the name dog, and we have defined a non-returnable function method bark. So taking the interface as a template, we can then implement the behavior. So using this class poodle which implements dog. This means poodle class is derived class from the dog, and then we have the specific implementation of this method here. Let's consider an example to illustrate further the ISP in C++. Suppose we have an iWorker interface that defines methods for various type of work such as work, eat, sleep. If you see here we have one larger interface which is iWorker, and we have three functionalities behavior here: work, eat and sleep. Now we must have to define the derived classes, clients, which will implement these behavior in detail. So we have three classes: public class human worker inherited from iWorker, public class robot worker inherit from iWorker, and then we can take many other classes also. So at the moment we have two classes here that are derived from iWorker. Okay, if you see, this is the concrete, these parentheses show we can put any concrete detail here, but this class will implement all of these classes. So human can work, yes. Human can eat, yes. And human can sleep, obviously. But if we see here, robot worker work, yes. Eat, no. Sleep, never. So this means this class which is derived from this interface must have access or must have concrete implementation, can have concrete implementation of these method, which is usefulness, which is not useful. So this means we must have to break down this interface into two more sub interfaces. Here we have we decompose the main interface into three interfaces, smaller interfaces. The first is a iWorkable, iEatable and iSleepable. And each interface has a specific defined behavior: work, eat and sleep. Now if we see again these two derived classes, human worker, so human worker will be derived from will be inherited from iWorkable, iEatable and iSleepable. Okay, so this means human implement the behavior of this interface, this interface and iSleepable interface. But if we see on the other hand a robot worker, so it is inherited only from iWorkable interface. And if you see iWorkable, so the function here defined is iWork. So this means this robot worker will only implement the iWorkable behavioral method. So this means we have decomposed and we have now follow the ISP. Let's see another example from vehicle behavior, which is following ISP. So this code is written in C++ and have a detailed look to this example now. Class drivable. Okay, so this is an abstract class or simple interface that defines a contract for any class that claims to be drivable. This means any class which claim it is drivable, so it must be inherited from this drivable interface. And the method here defined is the drive method. So we put the word virtual. Okay, virtual void drive, okay, method is defined here. So the drive method is a pure virtual, meaning it has no implementation here and must be implemented by any class that inherit from the drivable. So when we limit the use of any method such that the method, the detail, the concrete implementation of that method can only be possible in the derived classes, so we will put the word virtual. And similarly, we have defined the interface, we have taken the interface flyable. So those classes which claim to be flyable must inherit from this interface, and the method inside defined is the fly method, and put the virtual method. The fly method is also a pure virtual function, so it must be implemented in any derived classes. Okay, now come to the derived classes. The first derived class is the car class. You can see here we have the class car, which is derived, means inherited from the derivable classes, and we have taken the void drive. This means here we have defined the method here and which shows the behavior only, but the concrete and detailed implementation of this method is in the derived class. Okay, so the car class inherit from the derivable, meaning it must implement the drive method. And if we see here the void drive constant override, the drive method is overridden from drivable and provides specific behavior for car driving on the road. And see out, the car is driving on the road. This line points the message when the drive method is called. And we see here we have class aeroplane, which is derived from both the drivable and the public flyable. Why? Because aeroplane can drive as well as fly, but a car cannot be fly. Okay, so on runway you can see aeroplane runs, aeroplane drive on the road, but its main functionality is to fly. So we have taken two function here. Okay, the void drive constant override, this aeroplane class implement the drive to print that it drives on the runway, and similarly it can also fly. So these methods are defined here. And if we see the class drone, which is only flyable, so two classes are only if we see car drivable, drone which is only flyable, and aeroplane which is both. So we have taken public void fly constant override. See out, the drone is flying in the air. Okay, now we come to this code, main code. Okay, So we have car, aeroplane, drone, so car is a class and we have taken the object car. Okay, so the car, aeroplane, and drone, these three objects represent the different types of vehicles. Which vehicles? Car, aeroplane, and a drone. And then we have a derivable steric derivable 1. Okay, n is equal to and car. Similarly, we have derivable steric and derivable 2 is equal to an aeroplane. So these are the 2 pointers. So the 2 pointers of the type derivable. Okay, one pointer is derivable 1, another pointer is derivable 2. Of both are of the type derivable, are created and assigned to car and aeroplane. Okay, so these 2 pointers of the type derivable, okay, are assigned to car and aeroplane object respectively. This allows you to call the derivable 1, okay, derivable 1 with arrow function, okay, drive, and derivable 2 drive. Okay, so this means both car and aeroplane can drive. Similarly, we have flyable 1 and flyable 2 pointers of the type flyable, and this first pointer is will come here, okay, in this aeroplane and drone object. Flyable and steric flyable 1 is equal to an aeroplane, and similarly flyable steric flyable 2 is equal to an drone. So the 2 pointers of the type flyable are created and assigned to aeroplane and drone, allowing you to call flyable 1 fly and flyable 2 fly. If we see in detail these function calls, drivable 1 drive calls the drive method of for the car, printing the car is driving on the road. Similarly, drive 2 into drive function calls the drive method for the aeroplane, printing the aeroplane is driving. And similarly, flyable 1 fly the calls the fly method for aeroplane, and similarly this one flyable 2 fly will print which one, message for which one, for the drone. Okay, so this means we have only 2 interfaces, and these have a specific behavior methods, and the classes derived can only be this means we will, if while deriving the any classes, we will see that either it is a derivable or flyable or both. So if it is derivable, so we will derive it from derivable class, while if it is flyable, so we will derive it from the flyable class. If it is both, like in case of aeroplane, so we'll derive from both. This means rather than taking a one larger interfaces, we have managed our code with ISP by decomposing this one interface into 2 sub interfaces. If we see this code, the result of both code are same, but this is without ASP. Why? Here you can see when we have abstract class vehicle, we have defined 2 functions, drive and fly. The car class is derivable from vehicle, and we have these 2 methods here. You can see car is driving on the road, car cannot fly. So if car cannot fly, so why we need to implement this? So this means the car is implemented both the methods of this interface. Similarly, the class aeroplane implement both the methods, and drone is also implemented both the methods, but drone cannot drive, can only fly. So we have taken 3 objects for class car, aeroplane and drone, and we have 3 pointers vehicle 1, 2, 3 of the type vehicle, and we have assigned it to these objects. Okay, so vehicle 1 drive, this means vehicle 1 pointer access this object car, and which functionality, both drive and fly. Similarly, vehicle 2 and vehicle 3, all these pointers access the methods for of these three objects. So result is same, but here ISP is not followed, and we have unnecessary implementation of the methods in the derived classes. So it is better to convert it to ISP so that we can achieve the benefits. What type of benefits? So let's see the benefits of ISP. Reduce complexity. Smaller focus interface reduce the complexity of the code base. Each interface serves a specific purpose, making it easier to understand and implement. So the implementation and understanding of smaller with a specific behavior class is simple as compared to one big interface. Improve maintainability. When interfaces are small and focused, changes to one part of the system are less likely to affect unrelated components. This leads to fewer unintentional side effects during modification. Enhanced flexibility. Clients can implement only interface relevant to them, allowing for greater flexibility. This makes it easier to change implementation or add new functionality without altering unrelated code. Lower coupling. With clients depending only on interface they use, the overall coupling between different parts of the application is reduced. This encourages better separation of concern with the code base. Easier testing. Smaller, well-defined interface can make unit testing more straightforward. Test can target specific functionalities, making it easier to isolate and validate behavior. Better code reusability. Code that utilize small focused interface tend to be more reusable because components can subscribe to only the behaviors they need, leading to a more modular design. Clear intent. By adhering to the principle, the intent of interface become clearer, making it easier for new developers to understand the purpose of each part of the system more quickly. And minimize the impact of changes. Since clients only implement the method they need, any change interface or its implementation minimize the potential impact on the other parts of the system, reducing the risk of introducing bugs. So this was all about the ISP. So if you want to bring these quality attributes such as reusability and understandability, okay, and maintainability, so we must have to follow the ISP, so the code management will become easier. So this was all about ISP.